Hello everyone. In this video I'm going to explain the effects of a net force, chapter 3.7, 3.7.1 acceleration. So what is exactly the acceleration? If you look at the definition of acceleration here, acceleration is change in velocity over time. And change in velocity means you have to look for v initial and v final, then you subtract them. So here you have v final or final velocity. Velocity means speed. And v initial, which means the starting speed or the starting velocity. Then you divide by the time interval. Delta t means here the time interval. The time for the change from initial to final. So that's the formula for acceleration. In order to solve any acceleration problem, you have to use this formula, which is very easy. Now let's take an example about this idea. If you read the question here, a toy car originally moving at 1 meter per second, so this is here v initial velocity or initial speed, is pushed by a child. After 30 seconds, the speed of the toy becomes 3.7. So here 3.7 is v final, the final velocity. And 3 seconds is delta t, or the time interval, delta t. Now what you have to do here is to plug the information in the equation. V final minus v initial divided by time, and you get the answer 0.9 meter per second squared. And this is meter per second squared is the unit for acceleration. Meter per second squared. So memorize the unit for acceleration. And what does 0.9 meter per second squared, what does that mean? Now, this means that the speed of the car is increasing by 0.9 meter per second each second. So that's the meaning of the unit. The speed of the car is increasing 0.9 meter per second each second. Then here we have the graph, velocity against time. Usually in the question you will see it this way, velocity versus time. So vs means versus. Always take the first variable to be the y-axis and the second variable to be the x-axis. So in case you have velocity time graph, usually we ask you about the slope. So whenever you have velocity time graph, the slope of the graph represent acceleration. So this is very important. The slope is equal to acceleration. Now, how do you calculate the slope of the graph? You can use many ways. One of the easiest ways is to use rise over run. Now, rise over run, the vertical distance, this is rise. The horizontal distance, this is run. So in case you do rise over run, you get the slope of the velocity time graph. And as we said, the slope represents acceleration. Let's now see this example or this exercise. An object was pushed at constant force along a frictionless horizontal surface. The table below shows how speed evolved with time. So in this table you are given time at the top row and speed or velocity in the bottom row. Question A, plot speed versus time graph, the velocity on the vertical axis. So here we have to choose a suitable scale for both of them. The time runs from 0 to 7 and the speed from 2 to 23. So here you draw vertical axis and then horizontal axis like this. Okay, once you plot the points, question B will saying to you, draw the line, the best straight line through the points. So on the time axis, you have the time from 0 to 7. So using a ruler, take equal distances here. 1, 2, 3, 4, 5, 6, 7. Starting with 0. The time is in second. On the vertical axis, you have velocity or speed, which is meter per second. Now, on the vertical axis, you have to plot the points from 2 to 23. Okay, here you have to choose a suitable scale for this process. A suitable scale means you have to choose a scale that fit all the numbers. Okay, let's extend this a little bit. Okay, so here let me start with if I say, for example, each one division is 4, 8, 12, 16, 20, 24. Now, like this, it can fit all the data for speed. So here I write 4, 8, 12, 16, 20, then 24. Next step, start plotting the points. 0, 2, first point 0, 2. So let's plot the points. Time 0 and y is 2. XY, you can consider them XY. So 0, 2 is here. Then 1, 5. 1, 5 is almost here. 2, 8.1. 2, 8.1 is almost here. Then 3, 10.9. 3, 10.9 is almost here, and so on. Then you connect the points that you got like this. Okay, so this is question B. Draw the line, the best line through the points and determine the slope. As we said before, to determine the slope, you have to do rise over run. So you can divide, for example, this distance by this distance. So the slope here, slope is equal to rise over run. Okay, I'm not going to calculate now because my sketch is not accurate. You can do it on a graph paper, it will be more accurate. Now, next question. How much did the velocity increase every second? The answer to question C is the same as the slope, which means the answer to question B is the answer for question C. That's the velocity increasing every second. Okay, which is the definition of the acceleration. Acceleration equals slope, and as we said, acceleration is change in velocity per second, every second. Next, did the body move with constant acceleration, and why? Now here, you look at your graph. If the graph is a straight line, in this case you see, yes, it's in constant acceleration. If the graph is a curve, this means it's not a constant acceleration. I repeat, you look at your graph after plotting. If the graph is a straight line, this means it's constant acceleration. If the graph is a curve, which means it's not straight line, it's not constant acceleration. Okay, next question. How would you describe the motion of the body under the influence of constant force? The answer is very easy. Constant force produces constant acceleration. Constant force produces constant acceleration. Force is directly proportional to the acceleration, and this is called Newton's second law of motion. So what is Newton's second law of motion? This is Newton's second law of motion. Constant force produces constant acceleration, or force is directly proportional to the acceleration, and the formula is very easy, F equal ma. And this is Newton's second law of motion. Okay, now let's continue. Here you have rigid and elastic bodies. Here you have to memorize the definition. A rigid body is one in which all parts maintain the same distance with respect to each other. Okay, what does resultant force or net force does to the do to the rigid body? It produces acceleration. Okay, let's go ahead and continue. Here we have define rigid body. You can use the definition from the book. Okay, what happens to the rigid body or object when an unbalanced force means resultant force or net force, acts on it? Give an example. It will cause acceleration. An example, for example, the driving force of the car can cause acceleration, or the net force acting on a car can cause an acceleration. Next, properties of and unit of masses. Now, the unit of mass is kilogram. And the mass is a property of matter that influences how much acceleration an object experiences when subjected to a force. Definition usually are taken from the book. You have to memorize them. Now here you memorize also the standard mass, which is 1.00000.000 kilogram, which means 1 kilogram. So the definition, or by definition, the standard mass or the standard kilogram is 1.00090 kilogram. Okay, let's see next. What is the mass of the standard kilogram? What is the symbol used for kilogram? The standard mass, as we said, it's 1. The symbol is kilogram, kg. So the symbol is kg. Next, here we have in the table. The table gives acceleration of a puck p when subjected to different forces. Now here you have the force is increasing. Draw a graph of force versus acceleration. Remember, versus means vertical against horizontal. So here again you do the same thing. On the vertical axis, here you write the force. On the horizontal axis, here you write acceleration. Then you do the plotting. For the force, it's easy. You can divide into 5 divisions: 1, 2, 3, 4, 5. Then you write F, 2F, 3F, and so on. And for the acceleration also you do the same thing. You have to do the plotting. You connect between the points. You got the graph. Now, can we write F proportional to A? Remember the sign. This sign means proportional. Can we write that F is directly proportional to acceleration? You have to look at the graph. If the graph is a straight line passing through origin, so you say yes. Okay, can we write F equal ma? Of course, if the graph is a straight line passing through origin, you can do that. Newton's second law of motion, as we said before, it's very easy. Force acting on a body is equal to the product of mass and acceleration. So F equal ma, that's the mathematical formula for Newton's second law of motion. Let's see now this example. An object's mass is constant property of that object. How can you find if an object A has the same mass as an object B? Now, in order to find whether they have same masses or not, you give them the same amount of force, same force, and if they gain the same acceleration, it means they have the same mass. Okay, now the unit of force is in Newton, capital N. So the unit of mass is kilogram, kg, and the unit of force or weight also, Newton. So any force is measured in Newton. Now, what is 1 Newton? 1 Newton is a force when it's applied to 1 kilogram, it will make it gain an acceleration of 1 meter per second squared. So that's the definition of 1 Newton. Let's see this example here. A force 1 Newton is applied to a mass of 1 kilogram. What acceleration will it produce? So here you are given the force. Here you are given the mass M. Okay? And we want you to calculate the acceleration A. So you start by writing in Newton's second law of motion. F equal ma. Then you replace in the equation. The force is 1. The mass is 1. Acceleration is unknown. So if you do the math, you can see acceleration is 1 meter per second squared. So acceleration equal 1 meter per second squared, and that is the solution. Very easy. Let's see another example here. A force of 2 Newton is applied to a mass of 1 kilogram. What acceleration will it produce? Now the force is given here. This is F. The mass is given here. This is M. The acceleration is the unknown. This is the way you deal with the problem usually. The given information, write on the given information the letter which is given to you, and then for the unknown write a question mark. Then use the formula F equal ma. The force we have it's 2, so here we write 2 for the force. The mass we have which is 1, times the acceleration we don't know. Clearly, if you do the math, acceleration equals 2 meter per second squared. Okay, next example. A force of 1 Newton is applied to a mass of 2 kilogram. What acceleration will produce? The same idea exactly. F equal ma, then you solve. What force applied to a mass of 3 kilogram gives it an acceleration of 4? What force means? The force is our unknown, so F equal unknown. And here the mass is 3 kilogram, so the mass is given to us. Here the acceleration is also given to us. And the question is, what's the force? So you can use Newton's second law of motion. Here you write F equal ma. So you are given everything here. The force we don't know. The mass is 3. So here you say 3 times the acceleration is 4. 3 times 4 equal 12 Newton. So the force is 12 Newton. Okay, here we have the exercise, same idea. You have to plot force against acceleration, also on a graph paper. Not going to do it here because you have to do it on a graph paper. The vertical axis will be F, because we're saying to you F versus A. Then is the graph a straight line? You can decide from the graph. Calculate the slope of the graph. What does the slope represent? Here the slope represents force divided by mass. Okay, the slope, as we said, slope is rise over run. And since F equal ma, so if you divide rise over run, it means you're dividing force by by acceleration. So force divided by acceleration, and this will represent the mass. So in this case, the slope represents the mass. Deduce the mass of the ice pack. The mass, the answer to D is the same as the answer to C. The slope is the mass. Next question, state Newton's second law of motion. Newton's second law of motion is F equal ma. In words, you can say the resultant force, or F net, is the product means multiplication, of mass times acceleration. Now in symbols, F equal ma. Give the units. The units here in for force Newton, mass kilogram, and a meter per second square. So here you have the units for Newton's second law of motion. Super easy. Let's now move to next question. A force of 6 Newton is applied to a mass of 3 kilogram. What acceleration does it produce? So again, let's see the law. F equal ma. Here are given F, which is 6 Newton. Replace it here. So 6 equal. The mass is 3, so 3 is here. The acceleration we don't know. Calculate the acceleration. So here you do the math to calculate the acceleration. You divide by 3 here and by 3 here. This means acceleration is equal to 2 meter per second squared. And that is the acceleration. Next question, determine the mass of a car if a force 2.2 times 10 to the power of 3 Newton produces an acceleration of 2. Determine the mass, also same idea, F equal ma. The force is given to us, so let's write it here, 2.2 times 10 to the power of 3 equal, determine the mass means the mass is our unknown, times 2, that's the acceleration. Now you do the math. In order to find m, divide both sides by 2 here and by 2 here. Cancel 2 and 2. So you can easily calculate it. It's m equal 1.1 times 10 to the power of 3 kilogram kg. This is the mass of the object, the mass of the car. Now let's move to part B. If the car started from rest, find its velocity after 4 seconds. Okay, here since you have the acceleration from question A, you can see acceleration equal V final minus V initial over T. Now the time, you plug it here, and the word rest means initial velocity is 0, which means here you plug 0 for initial velocity, V initial is 0, and the acceleration that you got from question A, you plug it here. Now our unknown will be what? In this case will be V final. I repeat, the acceleration that we got from question A, remember what was it? It was 1.1 times 10 to the power of, no, this is the mass. We have the acceleration. The acceleration we have it's 2 meter per second square. Okay, so plug here 2 meter per second squared equal V final we don't know, minus V initial is 0 over time, which is 4. Now if you cross multiply, you get V equal 8 meter per second. And that is the answer for the question. Next we have gravity. Uh, Simply here we have one formula. We can solve all the questions about it, which is W equal mg. Now to explain this formula, whenever you have the mass of something, you can calculate its weight. For example, if the mass, let's say 8 kilogram, find the weight. So here you see the weight is equal mg, the mass is 8, so 8 times the gravitational acceleration of the earth is 9.8, so you have to multiply 8 times 9.8. Okay, so this is very easy. To find the weight, you use W equal mg. Now what about if you have the weight and you want to calculate the mass? In this case, you have to rearrange this formula. So you write it, mass is equal to weight divided by gravitational acceleration. So you divide weight of the object by gravitational acceleration, you get the mass of the object. So that's all you have to know about this part of chapter 3. Thank you very much indeed.